Ruba Lab 1, Brendan and Aiden. We got step 4, the retracting splitter request for a log splitter. This is what schematic looks like before you put the line numbers and everything together. This is what it looks like after with the transformer connected. You have 240 volts going to 120, going through X1, going to your first circuit breaker, followed by line 1 going to your first control relay, label number 3. Then from your first control relay, line number 3 goes to your limit switch. Then from your limit switch goes to control relay 5 that is normally closed. That when this limit switch is normally closed, this will be normally open, activating the relay.
So the measurements we took were from X2 to circuit breaker 1, and we read 121 volts. It's to be expected. And then from X1 to X2, we again read 120 volts. It's to be expected because the transformer is converting 240 volts to 120. And then for the calculations, we use the turns ratio. So 240 volts going in, 120 coming out. So it'd be 2/1, 2:1 for the turns ratio. Then we used Watt's law. We measured 121 volts at 5.2 amps. So we multiplied the volts by the amps to get the total wattage.
So this is our finished circuit. From the schematic, it shows you have 240 volts going down through this connector tube, going to X1, X2. X1 goes through the transformer, comes out 120 volts, goes through your first circuit breaker, comes down line 1 to control relay 3, down to your limit switch, back up to control relay 5. Then from control relay 5 goes over to control relay 4 to energize this part. And then line 2 goes back up to X2 on the transformer. Okay, now with this turned on, glasses,
Yep.
safety first. Okay, now he's going to insert screwdriver to control relay 3. I'm going to twist this limit switch and control relay 4 should retract. Okay, good. Control relay 4 contracted. Now show them how you undo that.
You just push into control relay 5, and then
And it goes back to its normal state, simulating a log splitter retractor.